Hello, great students. I'm sorry, I feel a little sick today, but I'm going to try and make these two videos before the weekend. Sorry, I missed out on making this video for you. So, what we want to do today in this video is we want to convert points. That's all this is called, converting points. And which points do we want to convert? We want to convert polar points to rectangular coordinates, and we want to convert rectangular to polar coordinates. And the way we do that is really a couple of simple formulas that are fairly obvious. And I'm going to show you those things right now, how we get them. All right? So let's take a look at the diagram I have drawn. What we see here is that we've drawn our typical right triangle in a circle. Okay, there's the right triangle. Here's the coordinates. Now these coordinates could be an r theta. Here's a radius. Here's an angle theta that could map to that point. But they could also be mapped to by an xy coordinate. And so we need to just find some relationships between r theta, x, and y. And there are actually 4 of them that we can do that include all 4 variables, all right? And so here they are. Let me go ahead and shrink this here. Whoops. Let me shrink it and put it up here, and I'll show you the 4 relationships. Number one relationship is we could say that we could use our sine and cosine. We could go the sine of theta equals y over r. And so we're going to want to solve for y or solve for x. So this will lead us to r sine theta equals y. And this is just our normal opposite over hypotenuse formula, but it leads to something where we can take r and theta and convert them to a y. All right, the second one is the same way. We can do cosine theta is equal to x over r. And that we could rewrite that as r cosine theta equals x. And this one then gives us a way to convert an r theta to an x. So these first two, so what you can see here is we have 2 formulas, and we'll figure out which conversion it does in a little bit, okay? So give me just a moment, and I'll show you about that. Actually, the conversion that this does, I've kind of straightened it out in my brain now. The conversion this does, if you have these 2, is if you have r theta, and you know r theta, then if you write r sine theta and r cosine theta, then that will give you the x and y values. So this is how you convert to xy, okay? From polar. So polar to rectangular, all right? So what are the next 2 formulas we can get out of this? Well, one other thing that we noticed is we can do the Pythagorean theorem. That puts a relationship. So x squared plus y squared equals r squared. Or we could rewrite that as r equals the square root of x squared plus y squared. Okay? You can use either one of those. But this means if we have an x and y, then we can find the r. And then number 4, this one, we want a relationship between theta and the xy. And if we look at it, we can write tangent theta equals y over x. And that leads us to theta is equal to the inverse tangent of y over x, which, by the way, is also slope. I'll just tell you that right now. It's another way to find slope. Anyway, if you have these, then what happens is if you know xy, then you can convert it to an r theta using these formulas. So let's go look at a couple of examples. So guys, I'm back. Sorry, I had to go do homeroom, and so I did that. Let's try and go ahead and finish a little set of examples here for this lesson. So one of the things we want to do is we want to change polar coordinates to regular coordinates. And so suppose I have like 3 negative 2 pi over 3. Well, we know that x is equal to r cosine theta and y is equal to r sine theta. So we can use these to find xy. So all we have to do is plug and chug at this point. X equals 3 cosine negative 2 pi over 3. And we can simplify that. 3 times cosine of 2 pi over 3 is a negative 1/2, but cosine negative 2 pi over 3 is in third quadrant, so it's still negative. So this is negative 1/2. All right. And then that gives you negative 3/2. And then we can do the y value. Y equals r sine theta. So y equals 3 times the sine of negative 2 pi over 3. Now sine is also negative in the third quadrant, so this will be 3 times a negative square root of 3 over 2 for the pi over 3, because sine of pi over 3 is square root of 3 over 2. And then this gives us a negative 3 square root of 3 over 2. So we now have our x and y version, so we can say 3 negative 2 pi over 3 is equal to negative 3/2 x negative 3 square root of 3 over 2 for y. And that then is your solution. And that's all you have to do. X equals r cosine theta, y equals r sine theta. And then generally, if you have special angles here, you want to do it exactly. If it's not a special angle, then you can convert it to a decimal. All right? So let's go to the next slide. And let's take an xy and let's convert it to a polar coordinate. All right? And so if we take an xy, say we are given 2, negative 2, like this, that's our xy. We want to convert it to an r theta. So we're going to use, we know r squared equals x squared plus y squared. So we can go r squared equals 2 squared plus negative 2 squared. So r squared equals 4 plus 4, or 8. So r is equal to the square root of 8, which is equal to 2 square root of 2. All right? Now, and then now we want to do theta. And we know that theta is equal to the inverse tangent of y over x, so negative 2 over 2, which is the inverse tangent of negative 1. Now, we know the inverse tangent of 1 is pi over 4, so the inverse tangent of negative 1 will be a fourth quadrant angle. So this will equal negative pi over 4. All right? And so our ordered pair is 2 square root of 2 r theta. Now, because of this inverse function thing where you have restricted domains, I would like to check this out and see if they're kind of in the same place. And so if you look, 2, negative 2 is right here. okay? And then 2 square root of 2, that's the radius, negative pi over 4. So negative pi over 4 is this angle right here, and then you go 2 square root of 2 out on that, and you'll end up in the same place. So I'm comfortable that this is equal to 2 negative 2 in rectangular coordinates. Okay? Fair enough. So let's go on. So in summary, to convert a polar to a rectangular, you use x equals r cosine theta, y equals r sine theta. So in fact, I could write this as r cosine theta, comma, r sine theta, like that. All right? To convert from rectangular to polar, you want to use r equals the square root of x squared plus y squared, and theta equals the inverse tangent of y over x. And so therefore, you could write this as the square root of x squared plus y squared, comma, inverse tangent of y over x. All right? And that would be your situation of how to convert points. So the next lesson is going to be converting equations, and it's going to be very similar, use the same things, and we'll talk about that, and I'll make another lesson. All righty, bye.